Hi, everybody. Today I'll be explaining to you all uh, the concept of GraphRAG and what is the utility of GraphRAG, why do we need it, and how is it different from conventional RAG. So without further delay, let's get started. All right. So if you look at the utility of retrieval augmented generation, and if we just understand why we need retrieval augmented generation in the first place, the fundamental idea being that a large language model is independently trained on a gigantic corpus of data. And when you prompt a large language model, the answer that is provided by an LLM is from the data that it is trained on. Now, one of the pitfalls of that is the LLM might not have access to the most recent and relevant data. And therefore, it might be providing you information that is antiquated and plausibly fabricated. And therefore, to mitigate this concern, we we try to embed our language model in the definitive context. If you're working in a large corporation, the proprietary data can exist inside of your database. If you are working with PDF documents, the information and the context could be could be replete in those PDFs. Whatever the proprietary data is, we want to make sure that our LLM has access to that information so that when we ask the language model a specific question pertaining to that context, the language model is actually aware of the particular personalized context on which it has to respond. So that is the reason we uh, why we utilize a method like retrieval augmented generation to make sure that we are embedding the knowledge of our language model in our specific context. Now, let's actually delve a little deeper and try and understand what really happens when we implement a retrieval augmented generation. So consider a PDF document. Uh, before we even introduce a language model, we chunk our PDF document, we embed those chunks uh, using a vector representation in a vector database, and we make sure that we have a good retrieval algorithm in place that can retrieve the appropriate chunk from the vector database when we are providing a prompt. And then we provide the prompt and the retrieved chunk to a language model to summarize and return to us the requisite information that we need. Now, if you look at the mechanism of a simple vector RAG, we have a gigantic corpus of information. The utility of RAG is that when we ask a very particular question, it retrieves a specific chunk from the vector database, it summarizes the query, and it gives us the result. So it is very good at answering specific question from a very large data corpus. However, in specific real world business use cases, sometimes our requirements may change, and it may change in a very specific way. So rather than just asking this very specific question about uh, a very particular aspect of the data, I want to actually get some top level information. Now, the top level information could be a delineation of a specific theme that is part of the document. I could just ask, hey, what are the top five broad themes that is part of uh, you know this corpus? Or I can ask about two specific subdomains and how they interrelate with each other. There are a host of ways in which our focus may change from the absolute specific to a more broader context. So to give an example, so I work in the IT industry, and if you look at traditional MSPs and how they manage triage, there are a lot of different ways in which clients uh, can put forth a specific request within a ticket. However, it is not that difficult to compartmentalize all of those tickets into specific verticals. So, for example, server issues might be a vertical where we see, different clients sort of raising this issue in specific ways. We can have cybersecurity issues where we can have, a whole host of ways in which clients can raise cybersecurity issues. We can have issues pertaining to data governance. We can have issues pertaining to AI-driven solutions. So all of these sort of form the broader verticals under which clients raise a whole host of requests. And if you want to have a smart chatbot that sits inside of your triage and it can expedite your process of resolution for not engineers, then it's actually very important that we have specific mechanisms in place that not only extract information from very specific parts of the corpus, but can also generalize across different themes and subthemes. So that is where GraphRAG comes into play. Now, as the name suggests, what essentially a GraphRAG is rather than actually treating the entire corpus as this one single document from which I have to pick a very specific information, we use a large language model to actually uh, distinctly segregate themes and subthemes into different clusters, and then we have sort of interconnections between these different clusters. These different clusters represent this different themes within our data corpus. Now, as you can see, within clusters, you have extremely strong connections, and between clusters, we have somewhat weaker connections. And that is essentially how clusters are represented, when we sort of orchestrate a data science driven algorithmic operation on a data set. So this is the concept. Rather than specifically focusing on chunks, we focus on global sense making, where we basically try and find these global research networks that represent different themes that are part of our documents. As you will see when I will demonstrate the implementation of GraphRAG, it is a little different from the vector RAG. So in vector RAG, essentially, oh, I'm sorry, in vector RAG, we essentially chunk our document using vector embeddings. We embed and store those documents inside a vector database, and then we basically retrieve the relevant chunk from that is relevant to the query, and we pass the query and the chunk to the LLM for summarization. In GraphRAG, the chunking remains a constant process where the document is broken down into chunks. Now we use an LLM to basically design a knowledge graph out of those chunks, and we basically ask the LLM to find different entities and relationships from those chunks. And when the LLM is actually answering a question, the summarization happens across different communities. So one level of summarization can happen at the leaf node, which is at the lowest level. Another, summarization might happen at one level higher. And so we have these hierarchical community summaries where we start from the lowest echelon and we gradually move upwards depending on what the query really wants from us. So here's the architecture of sense making. So as you can see, we ask the LLM to pick out entities and relationships from the document. And then we have these pre-generated community summaries that are interconnected with one another. We have the lowest community summaries at the bottom, and then we group those to form higher and higher, group-wise uh, communities, one echelon on top of the other. So again, just to demonstrate to you in a much more cohesive way, so you have source documents, you prompt your LLM to form nodes and edges, and then you basically form graph communities from those entities and relationships. There are a whole host of ways in which you can do that. The lead-in algorithm is a very common algorithm that we use to form knowledge graphs with macro clusters. And then, as I mentioned, we have hierarchical summaries. So on the lowest level, you will have lead communities. One level up, we'll have intermediate communities. And then finally, we have the broadest generalization on top, which is at the root community. And the way in which, again, the GraphRAG works is uh, it basically pulls specific answers from community summaries, and then it synthesizes it together, and and it proposes a global answer from each of those localized summaries. There are ways in which you can evaluate your GraphRAG. LLM as a judge is a very common way in which we can evaluate our GraphRAG and its performance. And there are several benefits to using GraphRAG. You'll have comprehensiveness, you'll have diversity, and you'll have directness. And again, you can play around between looking at global answers, which are summarized, uh, community information, or you can also drill down and look for localized answers where you want specific information. So the GraphRAG actually provides you best of both worlds. Now, to give you a simple example of how this is actually implemented, so we basically follow the same procedure that we saw in the presentation. So first of all, so in a real world scenario, you will have uh, you know, you will have access to data from various different API endpoints. You will be getting data from a multiplicity of different sources. And accordingly, you have to sort of manage how are you going to structure the data in a way where you can provide that information to your GraphRag so that, it can then parse through all the chunks and start forming communities. But as we will see here, let me actually go on top a little bit. So we come down, we have, so if, so this is a static data set that I'm using. It's a, sort of a dummy triage data set. Just to show you guys an example. So first of all, we chunk the information as was mentioned. So we divide our data set into various chunks. Then we ask our LLM schema for entity relationship and claim extraction. So we are defining the LLM schema here. And then we actually run the LLM over those chunks so that it can then fetch the information and then store the information in in the form of entities and relationships. And then we basically normalize LLM outputs into nodes, edges, and claims. Then we build the knowledge graph using the LLM. And then we use community detection to basically detect the various communities which are part of the data set from the LLM derived entities and relationships. Then we design a report, and this is the part of the program where it's summarizing community information, and we store the summary of every community information in a data frame. So this part of the procedure where every single community information is being summarized and stored meticulously. When we visualize the knowledge graph, so this is what the knowledge graph essentially will look like. You will have different nodes that explicate different themes that are sort of part of your knowledge graph, and then they will be connected to each other when they have a specific relationship with the other node. And again, this is not a an example that you will likely find in a real world scenario. In a real world scenario, you will have more cohesive communities where the sort of closeness will be much more conspicuous than what it is right now in this example. So this is the complete process of establishing uh, communities and community summaries, and sort of establishing an entity relationship style interconnection between them, so that now you can not only fetch specific information from your corpus, but you can also look at much more broader information across multiple echelons. So just to sort of sort of close the loop here, you will have a scenario like this wherein you can have sort of so for example, this is a triage dashboard. I can have a whole host of both local and global queries that I can give to my triage bot to extract specific information. So let's just say that I give it this information. I give it this question. For example, what does the triage demand distribution look like across all closed tickets? As you can see, this is not a very specific hyper localized information that I'm looking for. I'm looking for a much more broader response from uh, from my LLM chatbot. So once I query this, so the triage demand distribution across all closed tickets is high, 1249 tickets, medium, and low 156 tickets. So this is the summary from that. Then we can see, okay, which themes generate the most uh, high triage demands. Again, not a very localized question. It is at the global level. So as you can see, the knowledge base indicates the theme scientific studies and environmental data generates the most number of tickets. And triage demand is concentrated at the high level, 1249 tickets. Okay, so you get the gist. Now, let me actually go and, okay, what font should be used in report? This is like a very specific question, which is at a very local level. So you can also choose which mode you want. You query it. So as you can see, the knowledge base indicates the Times New Roman is the font that should be used in reports. Multiple tickets specify, blah, blah, blah. So you get the gist. So here you can see we are having a scenario where we are not only asking very specific information from our knowledge corpus, but we are asking it to respond to us across different levels, both at a hyper localized level from the corpus and also at a more general level across multiple tickets. So that is the utility of GraphRAG. Do give it a try. I would encourage everybody to read this paper from Microsoft Research, From Local to Global, a GraphRAG approach to query focused summarization. This paper perfectly encapsulates the utility of GraphRag and the advantages that we see when we incorporate GraphRags over a traditional vector RAGs. So that will be it from my side. Hope you give this hope you give GraphRag a try and let me know. Thank you so much.